Cotton wool. Clean processed cotton fibers, which themselves are made of cellulose. And cellulose is made of glucose, a simple sugar, a monosaccharide. With its 6 carbon atoms, it's a hexose. And with an aldehyde group at one end, it's also an aldose. Anyway, this is not a lesson in nomenclature. Basically, cotton is glucose held together with glycosidic bonds. Linear polymers consisting of thousands of glucose molecules that lay flat, allowing for strong, dense hydrogen bonding with other chains. Think of it like Velcro, only instead of hooks and loops, we can think of it more like tiny molecular magnets. The oxygen in the OH group pulls electron density away from the hydrogen, leaving it with a positive charge. Since opposite charges attract, it will bond with a negatively charged oxygen on another chain. To break this up chemically, we need a reagent that can coordinate with the hydroxyl groups. And that is today's compound, Schweizer's reagent. Schweizer. Tetraamine copper 2 hydroxide, made by reacting copper 2 hydroxide with aqueous ammonia. We first need to prepare a batch of copper 2 hydroxide by reacting copper 2 sulfate with sodium hydroxide. Just to demonstrate, you don't want to do this when the solution is hot or too concentrated, as you will form copper oxide instead, or a mixture of the two, as you will see here. So, like I said, we want our freshly made copper 2 hydroxide. We weigh some out, and we get our ammonium hydroxide ready so that we can react the two. On the first addition of ammonia, you can see that a dark product is forming. With more additions, the copper complexes with the ammonia to form a turquoise peacock blue solution. And this was another time I made it using a stronger ammonia. This is able to dissolve cotton by coordinating with the hydroxyl groups of the cellulose. Now we have a cuprammonium cellulose solution. We can precipitate rayon cotton with an acidic medium. Here I add a small amount of hydrochloric acid to water just to make an acidic solution. In the dilute hydrochloric acid, the the complex breaks down, releasing free copper-2 ions. What we have is ammonium chloride and copper-2 chloride dissolved in solution, and the intact cellulose chains precipitate out.